Dervishi, you can tell us your implementation, your solution.
Um, I think I have in the way that I approached it, but I could still explain what I have and try to work it through. That's okay.
Where is Roger?
Here, I can start if
Mm-hmm.
you you want.
You can start.
Okay,
You
so
you can tell
sure.
on Word or you
Okay,
prepared presentation
okay, I will share my board.
on the Benaxac board, week 2.
Sorry.
You can tell your solution on the Knapsack board in Miro.
Um, Sorry, I didn't get it. Couldn't hear.
Uh, could I repeat or what?
Yeah, please. I didn't hear.
You can tell your solution on Miro board.
Oh yeah. Okay, so yeah, give me one moment.
You can if you if you didn't did what? Okay. You can write or type on desk.
Okay. No, I got it in Mio.
You choose
Uh, Multidimensional.
a multidimensional. Okay, I copy. Uh-huh.
Can you share the screen with us? We can see my.
I have a Lux,
Okay,
but
one moment, one
but
moment.
but okay.
It's loading. It's loading. Ay, Dios, no, 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 no quiero intentar. Just wanna, no, no quiero. No, no. Um, ay,
Are you fine?
okay, so, where's your screen? Okay. So, you can see my
Uh-huh.
screen? Okay. So, my task was to find a solution for multidimensional Naxa problem. What is the multidimensional Naxa problem? It's just the expansion of the original Naxa problem with n dimensions, but the dimensions in this case are we can see like the dimension, the weights, the n weights that item can have, and these weights can be like in uh, like for example, volume, some weight, date of expiracy, and this with that statement we need to find the maximum volume of these items by taking no more than the capacity in each dimension. Okay, so what was the solution? Well, I implemented a solution using the original knapsack problem, but under the restriction that we cannot overpass um, the n capacities. I mean, that means that we do the take or not take. If we're gonna take, we need to be sure that all the capacities will be fine. Will be fine before taking, as like the usual NAXA problem. In the other case, we don't take it and we continue with the next element. What's the problem with this solution is that it's NP hard. So for if we have many dimensions, then the solutions will be the complexity will be very large, and therefore we can we cannot find a fast solution or a polynomial solution. I think with a lot of dimensions and maybe a few elements, an AB solution would be more effective. But in this case, I implemented the solution for using DP approach. Yeah, and I will share my so here is my solution. You can see, right?
Yes, yes.
So first of all, we have the n, which is the number of elements, the dimensions, which are going to be the dimensions of the item. Then we start. We read all the we read the item, and we read the item and all the variables of the dimension, and then we read the value. After that, we have a vector for all the capacities of each dimension that can or NAXAP can hold. And then we go to initialize or knapsack, and we will use a vector of vectors to memorize our data, and we will do a top-down approach. So in the function, the recursive function, we have first is that if we have already passed through this node of data, then we know that we know the answer, so we will return only the what we have already found. Then if we reach the base case, then we will return 0. And this is what I was talking about. Is like if the weight of the current item exceeds the capacity of any dimension, then we will skip because we cannot hold in our knapsack. And if not, and then we will include to our knapsack to our knapsack, and or we can exclude. If we can include it, or we can pass, and then we will store the maximum value that we will get after computate this, and we will store in memo, and we will memorize it, and that's it. The complexity of this algorithm will be like something like O of n by m by c to the power of d, where n is the number of items, m is the number of dimensions, and c is the capacity, and d is also the number of dimensions. So that's why I say the complexity with too many dimensions will be like too large, and if we maybe have some few elements, and we can approach a naive solution, like will be like less, because it will be like 2 to the power of n by m, and then it will be less in that case. But I think the solution explains well my approach.
Who got other questions? Okay, show me your function dp again.
Okay. Okay.
You choose recursive approach.
Yeah, top-down approach.
Okay. Okay, that's fine. That's a good task.
Thank you.
You can get 3 points. Did you see I created new rating for you.
Okay.
Rating sheet for you.
I saw it.
Так. Press Roger. Так. Roger get 3 points. Okay, and who get points? Who got points? Jalal got points, 2 points, I think. And Darvesha. Where's Darvesha? Darvesha. Great, didn't work correctly. Doesn't work. Okay, next is Darvesh. Darvesh, uh, do you ready? Oh, I forgot. I turned off my microphone. My microphone. Darvish, uh, do you ready?
Yeah, okay, go. My code, I'm watching over my code now, and I made some mistakes, but I think I could correct them as I'm explaining it.
Mm-hmm.
I'll send the code on the chat. Hold on. Um, no, give me one moment to try that. Okay. I sent it on the chat. So my question is the multiple knapsack problem. Basically, it's similar to the knapsack problem, except you have multiple knapsacks. So you need to
We did not get anything in the chat. Are you sure you sent it?
yeah, in the Discord chat.
Ah, here. And okay.
In the Discord chat, I sent it. Everyone seeing it?
I don't see um, where you pass your solution.
It's in the Discord chat, the Comnata.
Option,
Yeah, it showed me.
general. Um, Option. No. Um,
It's in the
uh-huh.
chat of the room, not in the chat of option.
Okay, I see. Who's been?
I just reset it from the chat of the room to the official room.
Ah, okay.
So the problem was in the multiple knapsack problem. So it's kind of like the knapsack problem, except this time, as the question goes, you have multiple knapsacks. So I had to find a way to take distinct items and put them into different knapsacks that had different capacities, obtaining the maximum value possible while at the same time um, not going over the capacity of the knapsacks. So I tried to do the matrix optimization that was shown in the last knapsack problem. So basically we would implement a 2D array. The first thing I did was that I created a function called multiple knapsacks. So the user would enter the number of items, number of knapsacks, and then it would take in then it would take in three arrays, which are the weights, the values of the items, and the capacity of the two knapsacks in order. Then I initialized a DP, which is where the maximum value would be held, and I initialized it as a 2D array because I wanted to create a matrix that would mimic the number of items versus the number of knapsacks. And I did number of items +1 and number of knapsacks +1 because I wanted the 0th row and the 0th column of DP to be just zeros. So that would be like the starting sum. And as I add the values to that array, to that 2D array, it would take the zeros as the starting point and then recursively add the sums while storing the values of the sums that we calculated before. So that's the whole dynamic process there. After that, I ran a for loop to initialize the 2D array to 0, and then I wanted to create the maximum value as 0, which is what would be used as the maximum value that could be obtained before we pass the capacity. I also did a check for the remaining capacity. At the beginning, the remaining capacity would be equal to J minus 1 because J minus 1 is the weight of the knapsack. So at the beginning, when the knapsack has nothing in it, it has full capacity. As that goes on and items are added, the weights of the items would take away from the remaining capacity. So underneath there, I have a for loop which would recursively take away weights as we go on. However, while the remaining capacity is greater than 0, meaning that we still have space for items, I added the item. I took the value of the item and I added it to the value of the item right before it. And then I also have a variable that does a check for the current value that I'm using, and then I would just return the maximum of those two. So basically what the entire calculation does is that it does a check to see whether or not the item that we are trying to put in passes the capacity or not. If it passes, if it means that if you put in the item into the bag and it passes the capacity, then it fails the test. So it would move on to the next item. If you could put the item in the bag and there's still remaining capacity in the bag, it means that we could do a check to see whether or not the value passes the second test, which is the value of the added on weight greater than the value of the weight before. And then we just return the maximum of those two in the DP, and that's the code.
Why don't you put area maximum value without current item?
Why don't I put?
Why don't you put to your maximum the value without current item? The variable without current item.
I have int without current item.
No, without current item, yes. Why don't you put to your maximum?
That is the I have that in the remaining capacity. DP K minus 1J. That was just a small check. I don't actually use that variable. I just had it there to remind me that value of the if the current item would be that variable without current item plus the value that I'm adding on. I do actually use the variable, but I just had it there as a reminder that this is how it recursively adds on the values over time.
Okay, okay.
It should actually be a comment because when I was making the array last night, I had trouble figuring out how to recursively add on the values to the matrix. So I just had it there as a check.
I see.
If you look at the with current item, I could actually take the dpk minus 1 and J and replace it with without current item. I just had it there as a check.
I see. That's good. I think I don't see mistakes.
Nice. I think I messaged about, I said that for simplicity's sake, I would have assumed that everything is an integer value. So the weights would have been integers. The number of items, the number of knapsacks would be integers because you can't have half an item and half a knapsack. In reality, the weights could be double or float. The values could be a double or float. So I guess to make a better code, these things could be changed to like doubles or floats. And also I wanted to use better memory management. I could have used pointers as well instead of having to keep on copying the values all the time. But it was 12 o'clock in the night and I was too tired. So
Send me the corrected code later. Send me send me the corrected code later. Okay?
yeah.
And I give you points. But now I check the solution and give you points. Okay?
It's good?
Sure.
All right, thank you.
Who prepares solution? Else. So, I can explain to you how to implement graphs. You will solve a lot of tasks on graphs, and implementation should be the similar. So graph is data structure. So its implementation should be in class. So let's consider its implementation. Do you see my you don't see. Just
I see it actually.
okay. I record on OBS this. So OBS this. Just okay. So you have let's implement adjacent matrix. solution for the graph. Okay. What do you have in private field? In adjacent matrix implementation, not adjacent matrix.
Common controls.
Сейчас adjacent lists. Сейчас как это называется? Ага, adjacency list. What do you have? You have vector of vectors. Vector of vectors. That will be size t for vectors or for to store the vectors, to store the vertices. You just contain size t type. It will be your graph, and you contain size of edges. So the another constructor will be contain vertex count and we can just assign our graph with this vertex count and vectors size 10, just a constructor, this call constructor, and we have another constructor. It will be the same, but it contain the count of edges. Okay. The ID structure will be default because we contain vectors, and vectors are already implemented default constructor, default structure, and here it delete all the memory when we call default constructor or default constructor. We have methods like add edge, has edge, and size. Okay, add edge. If we consider tail, if we consider unordered graph, we just put to this graph, we just put with the vertex head, we push back what? Hashback tail. We don't call in place because we call pushback, we call in place, and we call pushback because it's this type is сейчас как-то is simple. This is just sister. If it was vectors or something like that, we call in place. We will call in place. So you can read why we call pushback when we call pushback and in place. I I sent you to the chat an article about this. Okay, and we want to ask questions like has edge between this vertical and this vertical. All the implementation will be can't access the course. Так, потом. So, how do we can how can we check it? It can be checked for all again, but all one, but we need an ordered map. We need an ordered map. We need complex when complex realization, and in simple realization it will be we just check all the we just check all the edges. If graph head equal to tail, we just return true. Otherwise we return false. So так. Let's have a break for 5 minutes. Okay, so let's continue. What is another? What is? It will be another method. We want to get next get all the сейчас. We want to get all the дочерние, как вершины. Сейчас.
Black.
Дочерние сейчас. Нет. Сейчас.
Rishi, answer.
We want to get all the verticals that all the verticals that we can reach from considered vertical. So we want to implement get next method, but we don't want to change them. We have a parent vertical, and for this vertical we want to get all the verticals that we can reach in this from this edge, from this vertical, okay, by edge. Так. Асайста. So that's all the implementation of ordinary graph. I think we lost methods like size. Graph parent, graph size, просто all what verticals we have, and what is the count of edges. Edges count. We can write size like this according to Google code style. Just count and just count, I think. And it will be const. That means we don't change our graph data structure, and it will return just the count of edges. I think it will be better if it will edge count. Так. Где, как исправить format name, где refactor? Ладно, just count. And forgot to we forgot to push to update our счетчик counter. So I think that's all. No, and sometimes you want to delete, I think, edge, but in task in this task it will be useless. So that was an implementation for unordered graph, simple unordered graph, but we want to implement it so we can use specializations for ordered graph, but I think it would be better if I do an order class and change it, and after I will show you how to use templates. So what will be different? What will be different? So once again, what will be different from for this implementation for unordered graph? We just we want to implement ordered graph implementation. What is different from unordered graph implementation? You can look to your. Смотрите, look, in this implementation I push two edges in
In another graph, I guess it's like edges don't have direction.
You
We are
don't
not
have
giving
the
the direction.
so this edge will be just we don't update. Just we just delete this line, and this will be ordered graph, I think. Так, and has edge implement. Ну, это то же самое. It's the same implementation. Да, вот. In one line we have the difference in one line. So we can continue. We can consider VO graph implementation. I mean VO. Сейчас. VO graph implementation. Сейчас. Почему ничего ругается? Не знаю почему. In VO graph implementation we consider graph with weights on edges. With weights on edges. So we in this implementation we have a struct. We want to we want to contain struct like struct pair, struct, сейчас как его называть-то? Let it be, назвать, ну, давай just edge, and it will be contain what? It will contain vertex, tail, and it will be contain weight. Нет. Ну, cost or weight. Okay. It will be better if it just weight, and it have template class T weight. So, but this we want to use the structure only in class flow graph. So we just put this. We don't want to call edge from other classes, and we just put this implementation to this graph, to this flow graph. So, так, and in the graph we will contain edges like it will be edge t, and we need to point out that what weight we use, what type of weight we use here. This type will be put to this, okay, and it will be used this. So we have a lot of work. If you want to use this edge in here, we just put it here. So, and it will be of ht. Так, что-то неправильно. Not ht, просто edge. Just an edge, and here's just an edge. So we just contain these structures, this structure in our graph. Так, and here it will be a vector of edges. Here it will be we want to put not only edge, we want to put the weight, the t weight, this edge, and we put just we in place tail. We have a structure. We can in place tail and weight in this way. And we check that we have tail like not like this. We just as in our graph we have edges. We just do like this. Do check like this, and so that will be all. I think it will be edge, and that's all. So, когда мы заканчиваем? У вас это будет сейчас.
12:10, по-моему.
Ага, okay. You have two approaches. Of how to build our data structure. You can use pattern. Смотрите. You can use pattern. Сейчас я... Сейчас. Refactoring guru. I mean, if you continue to build, to define the graphs, you can get weight-oriented graph or weight-unoriented graph or weighted with the cost-oriented graph and so on. Have two. If you have two types of graph that can be oriented or are unoriented, and it can be weighted or unweighted, I think, and so on. You can get two. You must implement 2 to the power of combinations of classes to implement all the graphs. And you can use solution. I think I must change the window. I already do it. Done. So you can use structural pattern, compose, or just not this pattern. Do you know what is patterns? Do you consider the patterns in other subjects? I turn on the microphone. You don't consider, so it's very useful for all the developers must to know what is patterns. So we need to use, I think, composite pattern. Да, composite pattern. When you build a home, or not. Сейчас посмотрю. Ага. Сейчас. 1 second. Ага. No, so this, I mean, I think this is just in Russian. Ага. 1 second. Это точно тот паттерн. Visitor. Composite. Да, yes, that's this pattern we need to use. And so we have a graph, and we have many of combinations how to define our graph, and we just need to use just inherention for how to inherention, and so we can solve this task. We can define only combine only just not 2 to the power of combinations graphs. We define only combinations count graphs. We can define only combinations of count graphs. So нет, builder. It's what we builder. Okay, builder. No, not this. Not composite. We builder. What? We created graph, our interface graph, that will be that can be weighted or unweighted, or oriented or unoriented, and so on. And we can build our graph like this. Just we can use the builder and build our graph. You can read this article, this site, this refraction group site, and you know a lot of useful information for you. So we want to use builder, I think, for implement. And how to do it. we just inherit from our builder or our graph and so on, and we get we will get our graph. So and but the problem is we need to know what graph will be in statically, because we define this just because we define define this and this on compile in compile time, and we need to use specializations for building. So what I want to use okay, the graph can be oriented or unoriented. So let it be oriented,
Oh yeah, see your code.
just a bool. And graph can be what? Can be weighted or unweighted. It's a weight, I think. So we need to know this information statically because this struct edge, and for example, and we need to know in compile time how to store our graph, what kind of graph we use, and we just use specializations for this. Graph can be oriented or unoriented. It will be weight on or weights, and it can be not it can be сейчас как будет называться этот, it can be matrix or adjacency list realization. So так, that's an usual implementation. Okay, we just чтобы to do it more simple, it's more simple way, just create some graph, and this specialization this position, what will be? The oriented will be what? False. Сейчас. Так, я что-то не помню точно, как это. Точно. Не так. In this implementation, сейчас. The oriented will be false. The weight will be what? False. And the matrix will be false. This implementation. Сейчас нам не хватит. Template. Вот так. Окей. Вот. So, in this implementation, what will be the first argument? True, weight will be false, and matrix will be false. Wait, так, anti-plate. We need to put template here. This implementation. True. Так, true. So давайте let's not be the weight. We need to сейчас. We need to put here data structure of our edge. Сейчас. Это нормально? It will be normal or not? Yes, it will be normal. It will be normal. So we put true, and we in this we can just it will be class to weight the edge, I think, the edge, and the different the ordinary, just the default implementation will be nil. Так, and in this way we just put to our graph nil implementation. None, I think. I mean, and we just put in this template argument, we put this class th, and we need to redefine all of this. Do you have questions, or do you have questions about this? What I tried? you must you must ask a lot of questions about this. Once again, I suggest to you use builder design pattern, but in our implementation we need to know the argument statically. It means the builder design pattern нам не подходит. Okay, and we need to use specializations for build our graphs, and we just if we implement like this, it like this. Just new. We just define. We have definition of graph, and we have implementation of it. It's just a definition, and we have different implementations of how to implement our data structure. Nil data structure means we consider a default implementation of edge, and we don't so we must point out what class we use, but we just use пустышку. We just use nothing for edge. We skip this argument, and we implement it like this, and so on. And in this case, we need to implement the edge in, I think, we just if we use this, if we want to use the oriented weighted graph, we just implement the edge struct. It can be different. It can be different. It can contain a lot of arguments. For example, contain 2 arguments, 2 and what? And wait. And we just, if we want to use this structure, we just put the struct. Stop. We just put the struct to our graph implementation. The oriented will be true, th and false. True, edge will be our edge that we implemented, and matrix will be false. Okay, so we just use this implementation of graph. Consider you includes some library, and in template argument you can put your data structure that you implemented. It can be like this, by the way. In our main, it can contain our main. So in this case, okay, is in this case you что you put the edge. Сейчас you put just an edge. And so on. Ask question, guys. Ask questions, guys.
Would it be possible for you to perhaps send a question that we could practice? Because I don't think I could ask a question until I tried for myself.
Okay, you can please ask questions into the chat, okay? To the global chat, our chat. Okay. And you can, by the way, you can implement. I show you how to implement it more generally, but you can implement it. You can implement all the specializations in your solutions. You can just implement graph like this graph, like VO graph. Okay. You just call it VO graph and you use on the specialization. Okay. If you need some graph, you can just define it like VO graph and just an order graph, so on, and implement it and use it in your tasks. Okay? Did you understood me? Did you understand me? Okay. Or not? Ага, да. Ну все. That's all, I think. I'm waited for your voices. What you will be tell. Pin, by the way, and solve them. You can take tasks, remind tasks. Okay. Remind the tasks.
Okay.
So that's all.
Thank you. Bye-bye.
Спасибо вам большое. До свидания.
До свидания.